Today we will discuss angles. Angles are made from rays. A ray is a part of a line with one end point and one end going on infinitely. We name a ray this way. We can either use the word ray and 2 letters, or we can use the symbol for ray and 2 letters. The first letter always needs to be the end point. Now, a different way of thinking about rays is below, where we talk about opposite rays. If you look, it says BA and BC are opposite rays. Well, here's BA going to the left, and here's BC going to the right, so they're opposite. And I think that these 2 rays just look like. Now, when we start to talk about angles, an angle, I need to take off my highlighter. An angle is formed by 2 non-collinear rays that have a common endpoint. So when they say 2 non-collinear rays, they mean rays that are not sitting right on top of each other or not opposite necessarily. When they have a common endpoint, the common endpoint is called, let me get a better color here, is called the vertex. So that's where the 2 rays come together. Sorry for the sloppy writing. That's this word right here. So here we have ray XY and we have ray XZ, and they both come together at point X. That is our vertex. Now when we name the angle, we have some choices. We can name it with a nickname. So we can use the nickname X. We can use the vertex. We also see that there's a 3 sitting here in the vertex. That's a nickname, angle 3. Or we can name it with 3 letters. And there's 2 ways to do that here. Y, X, Z, or Z, X, Y. The vertex always has to be in the middle. So that's something to consider. When we write about how big the angle is, we say the measure. I'm going to highlight this because this is important. We say the measure of angle X, or we use a symbol from the word measure, M, and then angle X. That means measure. Now looking at these 2, what we're going to do is we're going to name the vertex, we're going to name the 2 sides, and we're going to name the angle. So let's do the vertex first. The vertex here, the vertex is this point where the 2 rays come together. So that's point D. The 2 sides will be rays. So here we have ray DC, and we have ray DE. So they're the 2 sides of the angle. So now when we name the angle, we can name it with the nicknames, or we can name it with the 3 letters. Now remember, that vertex has to be in the middle. So we can say CDE, or we can say EDC, but that vertex still has to be in the middle. Over here to the right, we have a vertex F. I'm going to write that here. F. We have array FG and array FE. Those are the sides. So I'm going to write those as rays with the endpoint going first. Now we have a couple of ways to name the angle. We can call the angle angle 4 because it has a 4 in the vertex. We can name it angle F with just the vertex, or we can name it GFE, or we can name it in the reverse EFG. Now remember that F, that vertex, has to be the middle letter. So what we'll do is we'll give you guys just a couple minutes. I'm going to pause the video. I'll give you these directions in class as well, but you're going to name the vertex point and you're going to name each angle. And you notice there's no numbers for the angle names. So you're either going to have to name it with the vertex or you're going to have to name it with 3 letters. Okay, so here the vertex is M, and we'll have angle M, or we'll have angle LMN, or we'll have angle NML. For number 2, the vertex is D, so we'll have angle D, we'll have angle EDC, or angle CDE. Notice that vertex is still in the center, in the second letter. For number 3, we'll have vertex R, so we'll have angle R, angle SRQ, or we'll have angle QRS. And lastly, our vertex here is T. I like to call the vertex kind of the corner. Like if you were walking these angles, you would have to turn the corner at that point. So we'll name it angle T, we'll name it angle STU, or we'll name it angle UTS. And that's one of the reasons we like to name the vertex first, because that reminds us that the vertex has to be in the middle of the 3 letters. Now, when we talk about how big the angle is, we can classify it. We can say that it's a right angle if it's exactly 90 degrees. We can say it's an acute angle if it's less than 90 degrees. We can say it's obtuse if it's greater than 90 degrees. Or we can say that it is a straight angle if it looks like a straight line. And those angles are equal to exactly 180 degrees. So that might be something kind of new for you. On this next slide, I'd like you to take a minute and decide if each of the 8 angles is acute, obtuse, right, or straight. Please classify them. We'll take a pause. Okay, so if it's less than 90, it's such a cute little angle, so it's acute. If it's exactly 180, it's straight. If it's exactly 90, it's right. Bigger than 90, but less than 180 is obtuse. Smaller than 90, smaller than 90, smaller than 90. Acute, 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 And bigger than 90, but less than 180 is obtuse. And I don't think this is new. I think you guys have seen this before, but always good to review. Now here's something that's possibly new. It's called an angle bisector. Now if you think of the word bisector, with bi, we think two. So like a bicycle has two wheels, that kind of thing. Now sect means to cut. So if we think of an angle bisector, it's a ray that divides an angle into two equal parts. So it's like taking maybe the amount of money that you have and cutting it in half, splitting it in half. You keeping half, you giving your spouse the other half. If you look at this picture, I know nobody wants to give away their money. I get that. If you look at this picture, JK is the bisector. And I'm going to label that. How do we know that that's the angle bisector? Well, here we have a big angle. And this ray is cutting through the big angle. And it's causing these two angles to be formed. You guys see the 63 and the 63. Well, that's your two equal parts. You've taken this big angle and divided it up into two smaller equal parts. So that means that the big angle was going to be 126. And what the angle bisector did was it took that 126 and divided it evenly in half, or 63 degrees each. Okay, it's like if you share a job with someone and you each get to split the amount of money that you make. These are two different kinds of angles. They're not something that we've really talked about before. They're called adjacent. And basically what adjacent angles are, they're like townhouses. If you've ever seen a townhouse or lived in a townhouse, you know that they share a wall. Well, adjacent angles are just angles that share a side, but they're right next to each other. See how 1 and 2 are right next to each other? And they share, and I'm going to highlight this, they share a wall. And the yellow that I just highlighted is like the shared wall. A special kind of adjacent angles, let me make sure I can write here, is called a linear pair. And linear pairs add up to 180 degrees. They're a special case because they lie along a straight line. So that's why they're called linear. And they're a pair because there's two of them. And remember, straight angles add up to 180 degrees. So linear pairs add up to 180 degrees. So we would be able to say angle 1 plus angle 2 equals 180. And we could maybe set up an equation. We're going to do that here in a little bit. Now this kind of angles are another kind that we see very often. Vertical angles, I'm writing that in here, vertical angles. They are actually not next to each other. Those are the kinds of angles that I like to think of as like opposites. Vertical angles are also congruent. We might not know or remember what that means, but that means that they're the same size and shape. So in this case, 1 and 2 are vertical. 1 is the top angle, 2 is the bottom angle. Also what we have are 3, whoops, I labeled that wrong, that's 4, Let me grab my eraser real quick. Clean that up a little bit for you. So that's 4 and 3. See how they're left and right. Left, right, top, bottom. So that's how vertical angles work. But how they really work is like this. If you find vertical angles, so see how this one is the left and this one is the right, and they share that common vertex, then you know this one on the left, right here, is going to be the same as this one on the right. They're congruent or equal. Same thing here. See how these two are vertical? One's in the upper right, one's in the lower left. Remember that this little box means 90. If you don't remember that, that's okay. We'll hit that next time. So those are two really simple examples of vertical angles. Let's try a vertical angle problem with algebra in it. Here you have vertical angles. Remember, vertical angles are equal. So we can write an equation that sets these two angles equal to each other. And you can plug that right into your Desmos. I'm going to go ahead and solve it. And you can solve for x, and that x is the x value that is going to make these two angles exactly the same to each other. Same sort of situation here. Here we have vertical angles, so we set them equal. So we can solve this in the Desmos calculator. We'll add 23. I'm just going to go ahead and solve it real quick. X equals 56. So for vertical angles, you set them equal. But if you look at these problems, particularly this one on the left, these are not vertical. These are linear pairs. See how they have a side that they share? They're adjacent, and they lie along a straight line. So these are not equal, not all the time. They can be, but they're not all the time, like the vertical angles are. So we can say x minus 12 plus x plus 15 equals 180, because linear pairs, they lie along a straight line, so they are equal to 180. So again, you can go to the Desmos calculator and solve this. Grab my calculator, get a little bit of help. We'll have x equals a decimal, and a lot of times that freaks people out. Don't worry, it's okay. So that's how linear pairs work, and I'm going to label this linear pair. That way, if you come back and need to look at it in the video again, you'll know which is which. Now, in this last example, it says find y, then find x. You can really do it in any order. I actually prefer, in this case, to recognize that here I have vertical angles. So I know what x is. I know that x equals 131. And I can write that in here, because the vertical angles are equal. Sorry I wrote so messy. Vertical angles. But the thing that you have to understand with y is that the 131 and the y are a linear pair. So look what happens when you intersect lines. Not only do you get vertical angles, but you get a linear pair. And I'm going to write linear pair. I'm going to abbreviate it because I'm running out of space. So here I would say the 131 plus the y equals 180. And if you put that in Desmos, remember that you have to use an x for the variable, not a y, and you solve it, you're going to get 49, I believe. So you would have 49 here, and you would have, see, these are vertical, top and bottom. So you have a vertical 49 and 49. You have a vertical 131 and 131. And then you have the 131 and the 49 happening all over the place several times. So we'll get used to those because those aren't going